So let's get started. All right, so basically what we wanted to do, or what I tried to do, was kind of pull out highlights from all the classes we've done so far. I wanted to kind of throw them up and ask.
Sorry.
And kind of ask, do you have any questions? Is there anything you don't remember? Is there anything you want to talk about? I'm going to make sure this was recording. It is. And see, and then we kind of go through each of the sections and just kind of talk it over. So, does everybody have a handle on the different kind of roles and responsibilities that we've talked about? Are there any ones that are super weird? All right, why don't we pull the room a little bit? So, what's the difference between a product manager and a program manager? Anyone? You?
I mean, I'm confused because the names are a bit interchangeable, right?
Yes.
But program manager, at least from what I remember, is someone who is more in charge of making sure tasks get delivered on time within the actual life or the cycle of the project, right? Or a part of the project.
So that's really a project manager. A program manager is a level above it. Okay. So to remember these, really focus on the first word because it really does tell you what it is. So product management is person responsible for the success of the product. Yeah. Okay, so
outward facing.
So it's outward facing, right? They're talking to customers, they're trying to figure out what it is we want to modify about the product to make it better. Project manager is let's get it out the door in time, right? It's all about the project to deliver something. Program is a little dicier just because of where you are in the world, in your life. You haven't dealt with this, but normally when you have a product, software product, could be a construction project, could be lots of different things. There's usually lots of different projects that all have to come together at the same time to actually deliver something, okay? It might be a building, right? You wanna have plumbing plus walls, right? So the program manager is responsible for the program, which is a set of projects. All right, so can anybody tell me the difference between an architect and an engineer, or an architect and a developer in software world? Although it's very, very similar to the construction again world.
The architect is basically the designer, and the software developer or the person that people really writing the code.
Right. Yeah. Right. So just be careful of the word designer because that also has overlap with visual design. But yes, you are correct, right? In the English word design. All right. So what's the big difference between site reliability engineering and system engineering? Or system administration.
One is deployed at runtime, to make system administrator is deployed at runtime to make sure if something goes wrong, they quickly make it put it back together and have it running as soon as possible. Mm-hmm. Versus the site reliability engineer is more in charge of making sure that long term things if there's some systemic issue within the system to find a more long-term solution for
Right. Okay. So that's correct, but the implication you have is that you might have both in a particular organization. That's really unusual. So the person who has this job, that's their focus, but they will also deal with things that are on fire.
Okay, got it.
Rarely, these people will deal with things that are on fire and will rarely also deal with trying to looking at it from a more systemic perspective, which is a good word. And that's why it's a big change moving, 20 years ago, there were only these. Now you're seeing a lot more of these because it makes a lot more sense. Because continuous improvement in software in general has become a big thing because this is why I often refer to software as much more like writing a book than it is like designing a building. Rewrite. Okay, is how it gets better, right? You're not going to come up with a perfect design. All right, next one. Some of the hot terminology that I think is important to kind of have in your back pocket. Almost guaranteed we'll put it on the test somehow. So just to kind of highlight, a couple of things. This one I really like, the abilities and illities, because this gets used in the workplace a lot. and if you stare blankly at people who say things like that, they'll get very confused. TDD and BDD, test-driven design, or test-driven development, I always say design for some reason, I don't know why, is a very big deal right now. I would say many organizations are doing it now. Behavior-driven design development is also starting to be popular. It's funny, my first exposure to it was probably 20 years ago, and it still hasn't really taken off. It's just kind of like there in the background. You'll see it in some special organizations, but it is actually a much more interesting way of doing this.
What's BDD again? Like
behavior-driven development.
Yeah. But what is it like?
Oh, so the idea is like instead of describing, so a test-driven development is literally like writing a test that says, when I add these two numbers together, I add 2 plus 2 and I get 4, right? Behavior is when you talk about it in the more abstract way, and so you have, generally speaking, you have someone who's not a programmer writing your tests, but you do it in such a way that it's actually executable. So, I can't think of a great example off the top of my head, of course. But the idea is that, when I add two numbers, I will get the addition of them as the output, and then here are a set of numbers to add and their output values. So it sounds like a pretty subtle difference, but if you see it kind of on paper, one is written in code and says, literally, if 2 plus 2 equals 4, then, or if, passing 2 and 2 to function A gets back 4, it's correct, right? It passes the test. Whereas the behavior, you describe the behavior, and then there's an interpreter that actually compiles it into more like programming language. So there's a really good Python library for it called Behave that has really good documentation, really good examples if you want to know more about it. LAMP is the granddaddy of them all, of these kind of 4-letter acronyms that describe a web architecture. Mean and MERN are probably much more popular these days, but these are thrown around all the time. So you kind of have to know roughly that first that they're an acronym, second roughly what they mean, and they will change, but you start to be able to guess what they change to, because if you know Angular is being kind of superseded by React, well, it's a pretty good guess of why that R is there, right? Whereas this was Angular, right? So you can kind of see the differences as you get to watch the kind of industry. Another really important one to me is orchestration. It's really important to most software, and is the hardest code to write a lot of the time. So I will probably, I generally talk about orchestration a lot. Feel free to jump in. Oh, sorry. Any questions? Anything specific anyone wants to ask about? Oh, sorry.
So how would you define orchestration, besides the fact that it's the hardest to write?
So generally speaking, is like, especially these days, there are not, like software systems that don't interact with other software systems essentially don't exist, right? All systems are made up of other systems. So when we're talking about kind of our different work profiles, when you talk about the kernel, you have all these different subsystems that are working together to actually make the computer run, right? When you talk about big online web applications, it's a whole mess of microservices. Conceptually, it's just you have a whole bunch of different relatively independent software that needs to be in the same place at the same time, working the same way, kind of connecting in the right way to actually deliver the service that you're trying to deliver. And so usually orchestration is, I probably actually look up an English definition of the word, really. But the idea of it is that all of your software now is kind of distributed independent components that work together to deliver a service. And if you don't keep that in mind whenever you're building almost anything, you're gonna have a really hard time. Even just wrapping your head around it.
Well, can I use this to some APIs? Say if I'm building an app and then I use like 3 or multiple APIs, is that the same thing like orchestration?
Yeah, so that's one way you're doing orchestration. You're using external third parties or whatever. What happens when one of those APIs goes away for the day, right? Because they went down. What happens when they change their security models? You have to log into it differently as the server side, right? So all those different things that you need to think about because you have all these different services working together. whether they're provided by you, whether they're provided by third parties, whether they're provided by partners. It doesn't exist for you not to have lots of different services, with possibly the exception of desktop applications, which are quickly dying out, right? They're all turning web-based, even if it's web-based on your laptop, right? Or like, half your phone apps are actually all web applications that happen to have like a specialized browser, right? Electron is a good example. Probably won't talk too much about blockchain or big data. Just kind of know they exist. If you get into one of those specialty areas, go learn about it. But in the general kind of software development case, there are things that you should know about, but they're not things that you should know well or need to know well. That may be changing with machine learning. All right, so wanted to hit on security stuff too. So just kind of review, I don't know how much you follow it, but if you look at something like I got pawned. So PAWN is the slang for somebody breaking into a system, right? Or breaking into an identity, really. So there are various websites. One of them I think is called I Got Pawned, which will tell you about basically all of the security events that have happened to all the big companies, yesterday. Constant attacks. If I put, you guys all know SSH, right? Secure shell. So I can secure shell into my house at home, okay? Because I want to be able to access the computers there. I will never ever put it on the proper port that a secure shell is supposed to be on, because otherwise all my machines will be just dying responding to attacks. They just get constantly attacked all the time, every minute of every day. Sometimes so much so that it actually uses all the CPU and you can't log into it. So there's various tricks around avoiding this, but I just cheat and put it on the wrong port so that it's much harder to find. It doesn't obviate the need for security, but the point being is just the attacks are so constant that it actually will tear down your machines. So knowing what's going on, right, about what CVEs are out there, what the latest and greatest cross-site scripting attack is and how to do it and how to avoid it, and more importantly, are really important, right? It's really important that you keep track of that stuff. It's really important that you keep track of the systems that you're relying on or that you're developing and knowing what things they might be vulnerable to. Even as a non-security professional. Any questions about this stuff? Did I tell you last time, or when we were talking about this one, where a guy demonstrated passing a video from one AWS server to another, which had no shared credits or anything? The way he did it was by basically guessing what was going on in the physical machine underneath the VMs. So he actually was able to pass a full video stream from one VM to another with no talking between the two, by just looking at what was going on in the physical server. So people are smart. Constantly will be attacking in new and different ways. Any questions about this? Oh, did somebody say something? No. Very close. All right. Be familiar with all of these terms. We covered this a bit in the quiz. We're not going to ask you what every flag is on them, but you should know what they mean, and you should know how they work together and why you need which one when. This is kind of the workflow we've been talking about kind of over and over again. So it's both the workflow that you expect in most open source projects, it's the workflow of most kernel developers, it's the workflow of most software development in general these days, unless it's a real traditional house. So you should also be familiar with roughly these steps, right? And these are somewhat euphemistic for the actions that we're talking about, right? You make your changes, then you make sure that your changes are aligned with the latest and greatest from whatever you were changing, which is what a rebase is. Then you request that the change that you've made gets added to the main line. And then kind of if you're in the reverse position, or you wait for basically a code review of that change request, and then there's a merge that actually makes it show up for everybody else. Questions, thoughts? Everybody know what those mean on the left? All right.
So you know what's checkout?
Checkout, Git is super weird. In all the other ones, it makes a lot more sense. Checkout is like, I want to go and use like this version of the thing. So if you have like 6 branches, you say checkout branch name, right? Or you also use it to kind of you can also use it to like reset to whatever you got originally rather than with your changes. So it's, I don't know, it's a very weird construct, but you end up using it a lot.
What is PRs?
Pull request.
Oh.
And just keep in mind, PR is somewhat GitHub specific. I'm not even sure where it origins.
I think that's where it's
Is it GitHub? Yeah, because GitLab actually calls it a merge request. I will often, I think I just said it, will like request for change. You'll also see, so it could be a lot of different things, but that's the one you'll most commonly see these days. And what's super bizarre about it is the terminology is backwards. So that's the one way to remember, right? Is that why are you pulling when you give someone else something? But it's related to the git pull command, that's why. But, all right, I also wanted to highlight, so when we were doing the kind of 2 different kind of work profiles, this was Bandon's side, this was kind of my side. So kind of be aware of the differences and why those differences might exist, because they're can be important when you're trying to interact with other software developers. You know, if you go to the builds club, for example, you're going to have very different technology conversations to some extent about how they do things, why they do things, than you will if you go and talk to, I don't know what club it is that does websites. You know, like it's into whatever, React or something. Because basically the community in some ways dictates the tool chain you use. And recognizing that there's different ones makes it so that it'll be much more understandable. You know, because if you're only used to using like VS Code and somebody comes along using Vim, you're not even going to be able to get out of the application. :Q, just remember :Q. Questions here?
You need to be familiar with all the editors?
You should have a good idea of like some from each camp, like 1 or 2 of each camp. You know, so like kind of here's some of the IDEs. These tend to be, you know, my side of the house tends to be more editor or more IDEs, although technically Sublime is really a text editor, so it's actually much more like VI. So be aware of the camps, be aware of, and like arguably Emacs is actually an operating system in and of itself. It is massive. It has, by default, it comes with its install with an AI built into it. So like that will answer questions. So be familiar with them. Be familiar with the language choices in the kind of different sides. That's kind of what I'm getting at when I would ask a question about this. Make sense?
Also, it's perfectly like normal to, based on your preference, to use something from the right for the left.
It's just unusual.
It's, yeah, it is just kind of not the norm, but if there are people who would, for example, use VS Code to do kernel development as well.
Right.
It's just that you won't see it as much. So if you have a strong preference for something specific, you would find out a way to use it for your task.
I think the transformation between the different platform or the different IDEs couldn't be like too difficult, right?
It is.
Like,
It is.
It's not actually different or difficult. It's what we refer to regularly as muscle memory. Is that whenever you're trying to switch from one thing to another, the muscle memory is tough. So, for example, like there's an old half joking, half serious battle between people who use Emacs versus VI, and in huge part, the reason is just because the way to do search and replace uses a different keystroke, one versus the other. And if what you're focusing on is how you're going to make this weird set of threads like work together and actually deliver on whatever thing you're trying to actually build, trying to get your fingers to do the right thing to move around in the file, not fun, right? Like it should be all just part of your muscle memory. This is part of why they teach you to type, like legitimate actual typing. Again, so you have the muscle memory to do it without thinking about it, so that you can concentrate on what you're actually doing. You know, and don't learn to type the way I did, so I can basically just type a lot of individual words very, very quickly. I can't actually type. It's very weird. So that's why it's difficult. And also keep that in mind if you're ever developing software. So like actually my wife got up today, had gotten an update on her phone. And on Android, you know, there's a little, I don't know, iPhone's well enough, but like there's a little pull down up at the top, right, that kind of has like turn off Wi-Fi or whatever. A new icon had appeared in between her Wi-Fi and her Bluetooth buttons. She was like, what the hell is this? I don't know what to do with this, right? Because essentially muscle memory, same thing, right? Is like, think about that in your software too. Whenever you want to make a change, make sure your finger's going to work. There's actually another great example from Liberty Mutual. A friend of mine worked on a big, massive project to take them off. You know what I mean by a green screen? So like mainframes to a web-based form for like doing insurance or something. And people, that once they rolled out the new software, they'd done all these user interviews, all this other stuff. They thought they'd made the software so much better and everything else. First day of using it, people were literally crying. Why? Because all of their muscle memory had changed. Even though it was on a mainframe and it looked crap, and you had to do things, you had to blink, you know, hit a million different things, they could do it so fast, right? They were so quick because their fingers knew exactly what to do. And this new web-based design thing was great for a new employee, but terrible for anybody who had actually been doing it for years, right? So it's really, really important, as stupid as it sounds. All right, sorry, any other questions? All right, so apparently Samara stole this from another professor, so I can't hit this too hard, but keep this in mind, okay, like kind of how this works, but also I want to know that MIT and Apache licenses are here, GPL is here, straight up copyright is here, right? You know, so just kind of keep in mind, here's the spectrum, so you should kind of know what the spectrum is, but then we should also know what a few licenses are and where they fall on that spectrum. Okay? Because when you're on the GitHub page that says create new repo, they have a little drop down that says license choice. I want you A, to pick one, B, to know which one to pick, depending on what you're trying to do. Do you know, here's another question too. Do you know why the GPL is considered a protected free license versus MIT? Do you know what the difference, like why that difference is there? So GPL is, as I think Microsoft's Ballmer famously said, GPL is viral. So basically, you put a GPL license on something, anything that you build with it also must be open source. Okay, so that's why it's protected, right? And I'm not wrong, right?
That's right.
Okay, yeah. Non-protected, MIT, Apache, in different ways, basically say, the thing I have built and I'm giving to you to use, you don't have to make things that you build on it open source. The GPL is really interesting right here when you talk about a SaaS provider. Yes?
I think he specifically said Linux is cancer.
He said that too. Yes. He said a number of awesome quotes. So GPL is really interesting here when you talk about a SaaS provider. So basically like an Amazon who's doing AWS. So if they offer a service based on an open source software that is GPL'd, do they have to release their modifications to the world or not? Right? Because technically that stuff should be open source if it's being used, but you as an individual aren't actually using the open source software, you're actually using the service providing the software. Right? You never download it. And the GPL was written originally for when the concept was you download every piece of software you use. So it gets really messy. That's why some lawyers really like working in the space, because it's really complicated. All right, any other questions? Well, I'll tell you one more random aside. In the proprietary license trade secret stuff, as a consultant, I do a lot of software for a lot of really big companies. When you were a big company, you would actually, part of your license, you would also buy, crap, I can't remember the actual word for it, but basically a vault where all the source code was that you couldn't access unless something happened to the software. But in order to protect themselves, like let's say Pfizer, who I did a lot of work for, to protect themselves from the fact that it wasn't open, would actually force the software vendors to put the software in, like I said, there was a special word for it, but a vault that was managed by a lawyer, that if that company ever became insolvent or anything like that, that Pfizer could access the source code so they could maintain their workflows. So this has a lot of ramifications that may not even be obvious about the fact that the code is secret. All right. What's the opposite of free as in beer? All right, free as in freedom. Okay. Problem with English, we have very non-specific words in a lot of ways. So that phrase was kind of developed a million years ago to indicate the difference between open source software and what used to be really common, which we don't see too much anymore, this concept of freeware. Software is still proprietary, still secret, but you don't have to pay any money for it. That's free as in beer, right? So free as in beer means you go to a convenience store or whatever and you buy a bag of chips and they give you a 6-pack of beer for free, right? Free as in freedom is when it's actually open source, you can actually access the source code. This is the ability to go and have a protest in government center, okay? Free as in freedom. Cost of ownership, this one is messy. Basically, one of the myths about it is that you have to maintain everything that you have a problem with, which can be true, but is also kind of not true. You can usually buy a service from somebody like Red Hat who will take on that burden. Related to that, which I don't think is on here, is a concept called indemnification, which is actually a big thing that people are buying from Red Hat when they buy our open source software, is if a portion of the open source software is discovered to actually be somebody's copyrighted code that should not have been in the open source license, they can't sue the person who bought the software from us. They have to sue us. Okay, so if you're a big bank and you're using Linux and you really don't want anybody to have the ability to sue you for any part of that stack, because it will be a multi-million-dollar lawsuit, right? So instead, Red Hat says, as part of our agreement for the sale, is that if you get sued, that lawsuit will actually be done by us, which is probably less of a selling point. It's still pretty important, but that was the only way open source could actually happen, right? Because there was one of the reasons why proprietary software companies existed and did so well is because it was secret, so you could just buy it off the shelf, like this Coke, right? And I can be guaranteed what I'm getting, and it's all just a black box to me. When the software is open, there's the possibility that somebody did something wrong, right? So indemnification was why enterprise open source actually happened. Let's see. Any other questions on here? All right. Any of y'all know the term whereas? That will definitely be an extra credit question. Speaking of piracy. And dating myself. You should definitely be familiar with kind of both sides of this. Like kind of what's the what I called it before, it's like what's the rough differences between open source and closed source software? Any questions here? One thing I will say about the patent remark, Red Hat goes after creating patents a ton. We create a lot of patents. Why, you might ask, when we believe in kind of openness of stuff? The reason is because we go after a ton of patents and then we put them not in the public domain, but in the public use, so anybody can use it for free. The reason we go after the patents is that so somebody else can't go get the patent and make money off of it, right? So because we think it's important that all knowledge be free, we as a result use the legal system to help ensure that be true.
What's the no discrimination?
So you have no ability in the open source world to keep someone from using your software,
Oh yeah.
right? So huge example, the whole Russian military, I think, runs on Fedora, right? We're not thrilled about that, right? Another great example is basically all the various software that's been used to break down the Chinese firewall. There was actually a great Wired article about this like a few years ago. Basically this guy who just keeps like writing new software and basically cobbling together open source software to break it in a new and different way every time he gets, not him tracked down, but his software gets tracked down and blocked. He finds new ways to cobble things together to break through the firewall again. And so no discrimination has two sides to that. These people we don't really like can use our software, and people we really want to help but can't distribute software to also can use our software. Make sense? Any other questions? Not even the last slide. Oh my god, and we're like out of time and we started late. That's a mistake. Alright, any other general questions?
The midterm is open world,
So we were talking about is this an actual term? Open web. Basically, it will not be very much in the way of kind of multiple choice questions. It will be much more like, I don't know, short answer. But the idea being is we're not going to ask you to define TDD. We're going to ask you why you want to use it. Okay? We also we think we're going to have an essay as well. That we're not sure exactly, but something along those lines. So it will probably be a fair amount of writing. I don't know, maybe we can do it digitally, because I can't imagine writing for an hour. All right. Any other questions? Oh.
But so when you say open web,
As in you can use your notes, you can use Google.
Oh great, okay. I can breathe a little easier now.
Yeah, just means the questions will be a lot harder.
Okay.
All right. Hopefully, the goal actually is to make questions require a lot more thought, and that somebody else doesn't do the thinking for you.
Okay.
All right, you have two questions up here. You're first.
Sorry.
Okay. Do you have a question, too?
Could you upload all the slides and videos on PDF?
That's way beyond me. There is a YouTube channel, which I did manage to do. So the videos are there, and I was actually just updating this morning, making sure they had links to all the slides. So they are all there, with the exception of not the last class, the one before that, because my SD card failed. So there's no video of that, but there are slides.
On YouTube?
Mm-hmm.
Okay.
And I think that link is in the
There is a link to it on the outside.
Yeah.
You don't see it?
I can't find anything like that, so.
Out of curiosity, after the midterm, what's the plan? It's somewhere there, but like, what are?
Like in the syllabus?
Yeah.
So like in no particular order, we have a guy who's going to come in who is a QE engineer and talk about what he does, and in some ways talk about what like the difference about doing QE at Red Hat versus doing it elsewhere, because it is quite different. That's one.
And we have a performance engineer.
And then we have a performance engineer also coming in. Performance engineering being that class of work where you either are proving the performance of your software or you're finding issues that are causing performance problems.
Could we talk about how to land the internship in the summer?
We could try and talk about it. I don't know how I would answer that.
This is too big, yeah.
It's a little vague. You know, I do know one of the things that was news to me is that if you want an internship for the summer at like some of the big software companies, you better be looking for it in September.
Oh yeah.
So like all of ours are closed. Like we have filled all of the summer internships before December, which is I think mind blowing.
I recommend asking your friends in August when they're like still at their internships for referrals.
References or referrals.
Because
Yeah.
usually you have to be like working at the company or get the referral, being able to refer somebody. So I started in August.
Right. So
Yeah, but for like a sophomore, if the last of October, it's too like too early for me to
right.
break.
So why don't we do this? We can look at it. I don't know how much there is in the schedule, but what we can do is, if you all have ideas or whatever, basically between now and let's say the midterm on Piazza, Samara, maybe you could start a thread of maybe we can reserve a class and say, here are the subjects we would like to cover in this class. So maybe we can do a little bit more of a rundown of internships, and then anything else you guys can think of. If we get like one thing, then we'll try to fit it in somewhere else. If we get a few of you say, hey, it would be really cool if we covered this, then we can add it. Because I can make up stuff about basically anything related to software. So
Could something we do be like actually understanding what Red Hat Linux is? What it does?
sure.
And that's gonna be applicable to just Linux in general. Why
Yeah.
do
But
you-
isn't the distribution you guys do slightly different in some way?
Nope, it's
No.
all open source. So first of all the software that we distribute, and we actually distribute something like 80 odd products,
Yeah.
way beyond Linux, like just tons of stuff. All of it's open source.
Yeah.
The only time it's not is because we bought a company and everyone's too embarrassed to release it, so we clean it up, then we open source it. Actually, it's also for legal review to make sure there isn't like proprietary stuff in there that got mistaken or something.
Yeah.
But like this kind of was implying before, when you buy Red Hat Enterprise Linux, you're not really buying the software. You're buying our logos because we have copyright on the logos, so that's kind of how we prove that it's RHEL. You're buying indemnification, so if you get a lawsuit or whatever about any component in there, they actually sue us, not you. And then you're also getting support.
Yeah.
And then lastly, and this is kind of less well known, you're also getting access to all of what we refer to as the upstream communities. So in other words, because we have so many actual software developers who are actually embedded in open source projects all over the place for all the different stuff that's in Linux. Excuse me, say you are a big company X and you really want to see some change happen. We can, and let's say you even wrote the code and you know it's good and everything else, you ran a performance test, that doesn't mean you're going to get it to land anywhere. So sometimes we also provide a route for you as a big company, or you as a developer, a big company, to say, hey, here's all this code I wrote for this thing that we really need. Can you get this to land upstream? And we can often help do that.
So it's all those additional services that.
So it's all those additional services, and then what we do is we take Fedora, we harden it, right, which basically means kind of go through it and make sure all the stuff that's there is we consider enterprise grade. Then we ship that.
Okay.
Then we make all kinds of promises about how and exactly when it will change.
So
'Cause that's another thing that's really, really important.
So just like a real example of this point is, this happens like really a lot, maybe not as much as today because Linux is very mature, but like Wall Street just runs on Linux and Red Hat Enterprise Linux. And so what they they have these like really complicated tweaks in the kernel to make their application just run like a microsecond faster. And what happens is then they update and everything breaks down, and then they start trying to figure it out again. So
Usually at $1 million a minute.
yeah,
give or take.
and then Red Hat steps in there and says, okay, this is the way you have to. If you do this change this way, and just submit it upstream, like to the community, it's gonna get accepted in Linux, the kernel, and then you don't have to worry about it at all anymore. It just gets in the kernel now. Maybe some other financial company is gonna actually add to it and improve it and you don't have to think about it at all. So this actually is a real example.
okay, I understand now.
Yeah. So it's weird, right? I mean, so in the sense that because, and this is a big part of the argument of open source, is that the brilliance isn't in the code. It's in all the stuff around it. So what is Facebook getting beaten up about? Not their code. Like React is open source. They have a PHP to C compiler for crying out loud that people use. That is how they make it go so fast. You know, yes, they have some proprietary code, but most of it they actually want to open source, but can't find good channels to do it in. What they're getting sued about is the data they collect, right? No one cares about the software, because it's not the software usually that matters. Maybe for like a minute, while somebody is like, hey, I wrote this really cool algorithm, whatever, and it does all this stuff well. But it's going to take like a minute and a half before somebody else is going to replicate it, right? Even if it's clean root. So that's what we're selling, is all that stuff around it.
So like, in other words, Red Hat is kind of like a way to capitalize open source.
We refer to it's not so much capitalize, like, because that's not quite what you mean, I think. It's a way to make open source safe, or enterprise ready is how we usually put
But
it.
also like getting like a community of people to constantly be developing that open source software, right?
Sort of.
Or like
Well,
with the know-how of how to like.
well, what's interesting about RHEL is that almost nobody actually contributes code directly to Red Hat Enterprise Linux. They always do it in the kernel, or they do it in GNOME, or they do it in whatever. And then RHEL selectively chooses from those upstreams what is going to be in the next version, right? There are some fixes and stuff like that that do happen kind of downstream or whatever. We always publish them back upstream, but we even carry patches, for example, that are open source but have not been accepted upstream. But that's why it's not quite true, but it's almost true that we're just an aggregator in a sense, of what we think is the best, and you're getting our opinion.
Got it.
Right?
Yeah.
And what we do to make our credibility is that's why we have so many developers in the actual communities, to make us credible for our opinion, and to arguably make it right. So, does that make sense?
Yeah, that does. Yeah,
Okay.
that makes a lot of sense.
Yeah, and if you haven't before, you should definitely check out some of our other stuff. Some of it's cool.